Hello everyone, welcome to the one of the most popular interview question that is nothing but your my SQL query is running slow today as compared to yesterday. Now before we move forward, please don't forget to hit the subscribe button below and also not to forget to click on the notification tab. Now this is one of the most popular question in an interview and this question can be answered at the two levels. That is nothing but at the SQL query level and at the database level. Now we're going to see what are the different aspects that you can address or answer in an interview at the SQL level first and then at the database level. Now at the SQL level, if your query is performing slow as compared to yesterday, the first and the foremost thing that you should be checking is whether your SQL query has changed its plan or not. Now, for example, you fired a query yesterday, select star from employees where employee ID is equal to 100. So yesterday it was running fine, but today it is not running fine. So first thing which we should check at the SQL query level is nothing but your execution plan, whether your execution plan has changed or not as compared to yesterday. Say for example, yesterday it picked up a good index, but today it performed a full table scan on the entire employees table, and that is the reason why, because of the change in the execution plan, your query took a long time to complete. So if you want to check whether the plan has changed or not as compared to yesterday, you can run this stats underscore hist script, which I have attached in the Google Drive link below. You can find the complete script details in the Drive link. So when you run the stats underscore hist script, you are going to get an output like this, which says the snapshot ID, the snapshot start time. Say for example, at 30th December 2019, 10:10, it took around, this is the plan. Yesterday, at 30th December 10:10, the plan was 9080711723. Okay, and it completed 2800 executions. And to complete this 2800 execution, it took 662 seconds only. But 20 minutes later, when you might have ran the same script, the plan has got changed, and to complete almost the same number of executions, that is 2856, it took 1500 seconds, more than 1500 seconds, which is double the time. So this data clearly tells that there has been a change in the execution plan of the script on 10:10 and later at 10:20. So execution plan is the first thing which we should check whether your query has changed its execution plan or not. Now the second thing which we should be checking at the SQL level again is whether the bind variable which is passed is good or not. So when I say good bind variable, it means it qualifies for very less number of rows, and when I say bad bind variable, it means it qualifies for more number of rows. So for example, now your execution plan has not changed. It has been running with the same plan as yesterday and today. Now the next thing which we should be checking is of course the bind variable. Now looking at this example, I ran this select statement yesterday, select count of star from employees where department ID is equal to :1. So :1 is nothing but your bind variable. So yesterday when I ran this script, I passed the bind variable 10 and it qualified for only one row, because of which it completed very fastly because it was expecting only one row. But today when I ran, I passed the department ID is equal to 20 at the runtime. Okay, and when I pass 20, it is qualifying for 100 rows. So even if the statement has taken the same execution plan as yesterday and today, since I passed a poor bind variable which resulted in too many rows being selected, my query has taken long time today as compared to yesterday. So the second thing which we should be checking is whether you're passing a good bind variable or not. The third thing which we should be checking is the index fragmentation. Now your execution plan, it has not changed. You are still passing a good bind variable which is expecting very less number of rows, and in spite of that, even if you are still facing that the query is running slow, it can probably be due to the index fragmentation. Now index fragmentation will happen when there are too many insert, update or deletes happen on the table. That means too many modifications happens on the table, and because of which the height of the B tree index level, that is nothing but your branch level, becomes equal to or more than 4. So in such cases, those indexes needs to be rebuilt so that the indexes will perform better. For example, suppose the query which you ran is using an index empid underscore idx, and yesterday and today it still used the same index. So you can run this analyze index validate structure. It's an uptime statement and doesn't cause any issues, and it populates the data in the index underscore stats table. So when you analyze this index and when you run the select height if rows from the index underscore stats table, you get an output like this. And if you see that the height is only 2, that means for this B-tree index, the height is only 2. That means there is one root branch and one branch block. So since the height is 2, it is not eligible to be rebuilded, which means that this index is not fragmented at this point of time. So the next cause for my query running slow at the SQL level is nothing but your index fragmentation. So the next aspect that we can be checked at the SQL query level is nothing but your high disk reads. Now your execution plan is same, your bind variable is same, your indexes is not fragmented. Okay, but when you ran the query yesterday, all the desired blocks may be in the cache. Okay, but when you ran it today, those desired blocks were not in the cache and you had to go to the disk and fetch those blocks. And now everyone knows that fetching the blocks from the disk is much time consuming as compared to fetching the same blocks from the cache. So this can be one of your next cause that yesterday the query was performing less discretes, but today it is performing very high discretes. So if you run this query, stats underscore cache, which I have again attached in the Google Drive link, you'll get an output something like this. Okay, and if I see it for the latest execution for today, this is a SQL ID of the script. This is the plan. Only one execution I ran it. And if you see the execution time is nothing but 1413 seconds. And if you see the discretes here, it's going for this much of discretes, 116, 267, 8 blocks of discretes. And if you see there is no buffer gets at all today. This means that when I ran this query today, I couldn't find my blocks in the cache. All those blocks has been fetched from the disk, which taken a lot of time to complete the query. So the next possible cause for the SQL query being performing slow today was that today it was going for a high discretes as compared to yesterday. Now that was at the SQL query level, the execution plan, the bind variable, the index fragmentation, and also the query going for high discretes. So these are the things which you can check at the SQL query level. Now coming back to the database level, here we've taken an example of the Oracle database. Now if you're running a statement other than select, that is insert, update, and delete, there is a high possibility that other statement might have blocked your SQL script, and that is one of the reason that your script is running very slow today, right? So there may be a blocking session in the database, and you can run this below script blocking underscore sessions, which I have again attached in the Google Drive link, to find out whether your script is being blocked by some other SID. Now, if you run a script and your SID was 343, and if you get an output like this means that there is another script running with SID 12, which is blocking your script. So this is also one of the cause that your script may run slow because it is being blocked by some other script. Now next cause again at the database level is nothing but your CPU starvation. So this means that everything is fine at the script level, but somehow the database server is having a very high CPU utilization, and this can be due to multiple reasons. Having very high CPU utilization means that the processor is not able to give you enough resources to execute your query. Now, in order to verify this, the first thing which you can check is always the top one foreground wait event in the AWR report, and if it shows CPU, and also if your DB time is much greater than the number of cores into the elapsed time, it means that your entire database is consuming very high CPU resources. You can check the OS Watcher log to confirm the percentage idle time and also the percentage user time. It is a very high percentage user time and very less idle time. It means that the database is CPU starved. So at the database level, you can always check whether you have sufficient CPU utilization available or not. Now that was about the CPU. The exact opposite cause is also due to the IO contention. So IO contention is nothing but there are other scripts which is consuming very high IO resources, and because of which the network bandwidth is not sufficient enough for your query to execute. So there may be IO contention by other scripts at the database level. And again, to check this, you can always check the top one foreground wait event in the AWR, and if it is user IO, and also if the DB time is much greater than the number of cores into the elapsed time, it means that your database is performing mostly IO operations, very high IO operations in fact, because of which it is not able to give you enough network bandwidth or IO resources for your script to complete. Also, you can check the OS Watcher logs to see the percentage idle time and also the percentage wait time. If the wait time is very high, that is nothing but your IO waits. And if the percentage idle time is also very less, it means your database server is not having enough resources for your query to be enough resources to be allocated for your queries. The next cost at the database level is nothing but your SAN latency, which means that reading and writing at the SAN layer or at the disk is very slow. Now this can be an issue at the SAN level, that is nothing at the disk level, where an Oracle DBA or any DBA can't do much here. So in order to validate this, you can always check the average read millisecond. That is nothing but the DB file sequential read. Whenever you do an IO operation, you will see a DB file sequence. Most of the time, it will be a DB file sequential read operation in the database. And if you can check the average read in millisecond for the DB file sequential read, if it is more than 10 milliseconds, you can say that there is a SAN latency issues. Also, you can check the table space IO stats and file IO stats in the AWR report for the average read in millisecond and average write in millisecond value. And if it is again greater than 10 milliseconds, you can say that the there is a SAN latency at the disk level. So now 10 milliseconds is just a standard. Ideally, that is also a very high value, but you can always compare that with a good time AWR report. And if in the bad time the millisecond delay is very high, you can confirm that your SAN disk is very slow. Now it can also happen when the other scripts are consuming very high resources or there is a very high IO bottleneck. Your SAN is fine, but your IO subsystem is very saturated. Now that can also be one of the reason for this SAN latency. Also, if you are noticing log file sync wait event, it will most of the time it will clearly tell you that there is an issue at the SAN layer. Now the last and the other wait events in the database is also one of the probable cause which can cause your query to run slow, because the database is busy in other wait events which are not necessary. For example, there is a very high cluster wait events if it is a 2 node rack or more than 2 node rack database. If there is a concurrency, that is your library caches are locked by some other objects because of which your query is not able to pin your object in the library cache, or if there is any network disruption. So these are the other wait events which can cause your query to run slow today as compared to yesterday. So I hope you liked my video, and please feel free to share your comments, your suggestions, and if you have come across any other aspect which can contribute to the query running being slow, please feel free to comment below. And I hope you like this video. Thank you so much.